Greetings everyone, and thank you for joining this Digit AMA. We'll be talking about the AMD Radeon RX 6000 series of graphics cards, which are based on AMD's latest RDNA 2 microarchitecture. This AMA is sponsored by AMD, and all the materials that we've been showcasing and we're going to be showcasing in front of you have also been provided by AMD. If you wish to get more information about these particular graphics cards, then we've also reviewed all three graphics cards from the RX 6000 series. This would be the Radeon RX 6800, the 6800 XT, and the 6900 XT. We seem to have lost one of the displays. Just a second. And there we go. We have it back, and hopefully that glitch is sorted. Again, now this is an AMA, so the format is that you ask us questions, for which you have the little chat function on the right side of the YouTube window. And if at all you've had any other questions, then please do feel free to share it with us on any of our social channels. We are monitoring that as well. And during the registration phase, we've picked questions from you while you're putting up your registrations, and we'll be answering those as well. If at all, again, you have any other questions, please use the chat functionality, and we'll be taking breaks along the way around every 5 to 10 slides just to answer whatever questions that you might have up until then. So, without further ado, we'll begin the presentation. We're going to go into the key features of RDNA 2, and that will show us how AMD has achieved the remarkable performance gains with the RX 6000 series. Then we'll be looking at some video game benchmarks as well as some content creation benchmarks. Let's begin. We'll switch. There you go. So when it comes to gaming, there are two key performance contributors, the CPU and the GPU. They work hand in glove, and AMD recently launched the Ryzen 5000 series of CPUs in late November, or early November, sorry, followed by the Radeon RX 6000 GPUs in late November, and then in early December. You have the 6800s come out first, and then the 6900 XT came out early December. We've already conducted an AMA on the Ryzen 5000 series of processors. Those are the Zen 3 processors earlier this month, which you can check out on our YouTube channel. And that's about it. Coming back to the topic, AMD has had these two fresh launches, and both of them have contributed considerably towards gaming performance. And we're going to look at GPUs in particular. CPUs we've already gone through. Now here we have RDNA 2. This is a successor to RDNA, that is AMD's latest GPU architecture, which was unveiled with the Radeon RX 5000 GPUs that were launched last year. And before RDNA, we had the GCN architecture for several years, and a lot of the GPUs were in the mid-range desktop PC segment. And with RDNA, AMD overhauled its approach towards raster graphics, which resulted in the RX 5000 series being really good in mid-range and entry-level segments. And now with RDNA 2, AMD has improved upon the power efficiency and managed to get better frequencies. Not only that, but even the video buffer bandwidth has been improved with AMD's Infinity Cache. And another key feature addition in the support of is the support of DirectX 12 Ultimate, along with Microsoft's Direct Storage API. The latter one is one of the key features which we have seen in gaming consoles, by the way. Now, RDNA 2 GPUs are all designed on the same 7 nanometer process that RDNA 1 was designed with. Over time, AMD has streamlined the microarchitecture to improve upon the power efficiency and also the clock frequency. On the right, over here, we have a graph which charts the frequency of the GPU against the power consumed per compute unit. The compute unit, just to add a little bit of context, is the logical segment of the GPU, which can handle the entire graphics pipeline, and RDNA 2 has achieved up to 1.3 times the frequency that RDNA 1 was capable of at the same power level. Similarly, if you were to keep the frequency at the same and then check the power savings, then RDNA 2 consumes up to 50% less power per compute unit. What this means is that the new GPUs are more scalable in terms of performance thanks to the improvements made with RDNA 2. Next up, we'll be looking at why one of the major changes was required with RDNA. And this major thing that we're talking about is the Infinity Cache. Now, with the RX 5000 series, there was a private L1 cache linked to a 4 MB L2 cache. Now, this was then tied to a 256-bit interface on the die, which gave 448 gigabytes per second of bandwidth. Now, that's good for, let's say, 1440p gaming and 1080p gaming. When you scale into the domain of 4K, you need a lot more data because 4K frames are much, much larger. For that, you can either solve by doubling up the memory interface to 512-bit, which in turn consumes a lot of power. So you might end up losing on the power efficiency savings by doing that. Instead, with RDNA 2, AMD did something different. They introduced something called Infinity Cache. Now, Infinity Cache is linked to Infinity Fabric, which you've heard of multiple times because it's used in other AMD IPs, such as the Ryzen processors and even on the server processors, which happen to be EPYC. Now, the Infinity Cache works with the Infinity Fabric and allows for much higher bandwidth to be provided to the GPU. Think of the Infinity Cache as a L3 cache, but a massive L3 cache. It's 128 MB of L3 cache placed right next to the GPU. So it's a lot of storage and it's very fast storage thanks to the Infinity Fabric interconnect. Now, this helps AMD to get a lot more performance because you can push a lot more data towards the GPU and then take out a lot of the frames and push it onto your monitors. This helps with high resolution gaming, as we saw previously. The whole focus of RDNA 2 was to get good with 4K gaming. And here we can see the impact of Infinity Cache. Straight up, we see an improvement in bandwidth at lower power. And then you get better frequencies because you now have more bandwidth to feed the GPU and also crunch out all the frames. And because the cache is huge and very close to the GPU, you have a lot more data stored much closer to the GPU, and you don't have to go all the way to, let's say, the RAM in order to pull whatever texture files that you need. What that helps in is to reduce latency, and that in turn helps you get better performance in a lot of games because quite a lot of games are latency dependent. Now, here we have 3 graphs showcasing the impact across all of these topics that we just spoke about. And now we'll move into the advanced features that were incorporated in RDNA 2. Now, there are several hardware accelerated technologies, including new features and APIs introduced within DirectX 12 Ultimate. We also have DirectX ray tracing or DXR, variable rate shading, mesh shaders, and sampler feedback. Video game developers need to factor in these features during the development process in order to take advantage of them. Already, we've seen more games make use of DirectX ray tracing in this quarter, including the recently released Cyberpunk 2077. And with that, let's take a closer look at the whole ray tracing aspect. Now, we've already touched upon how AMD GPUs are made of several compute units, which are all logical components of the GPU. Now, with RDNA 2 GPUs, each compute unit has something called a ray accelerator. Now, this is a dedicated piece of hardware for accelerating ray tracing within video games and content creation applications. And because the ray accelerator is present in each compute unit, the design becomes scalable. So if you add more compute units, let's say when you're moving from a 6800 to a 6900 XT, you get a lot more ray tracing performance because you're getting more ray accelerators. And that also makes it quite easy for developers to scale ray tracing performance in their games. They get a really good context of what is capable, let's say, of future GPUs should they have a similar structure. Now, to summarize, we've seen higher performance at the same frequencies. Then we've seen that the frequency can be raised to higher levels and it takes less power per cycle to compute. Now, all these three factors put together give you really high performance per watt gains. Now with every generation you do get performance per watt improvements, and in the next slide we'll be seeing the impact of the movement from GCN to RDNA and then from RDNA to RDNA2. Here we see that when AMD moved from GCN to RDNA, there was a 50% gain in performance per watt, and then the move from RDNA 1 to RDNA 2 saw an additional 54% performance per watt gain. And on the right side of this particular slide, you can see all the different features that contributed to this particular increase. You can see the design frequency increase, the power optimizations, and the per clock performance enhancement that came into play with RDNA 2. Also, the features that we spoke about, there is infinity cache, also comes into this particular order. Moving on, we now arrive at the three SKUs that were launched with RDNA 2. That is the Radeon RX 6000 series of graphics cards from AMD. We have the 6900 XT at the very top. Then it's followed up by the 6800 XT and the 6800. Now these are all positioned for different levels of performance, and they're all good for 4K gaming. So if you've been playing at 1440p or 1080p and you wish to upgrade to 4K, then the 6800 is where you start off. You could upgrade to any of these cards, by the way. And if you wish to crank up the settings to high or ultra, then the 6800 XT is more preferable for such situations. And for folks who'd like to not compromise at all and turn on all the bells and whistles that AMD can provide and game developers can provide within their video games, then you have the 6900 XT, which is really good even for ray tracing performance. Speaking of which, we'll move into ray tracing. Now, hardware accelerated ray tracing and ray tracing both have been around for decades, but it's only now that they've been introduced into video games, and Microsoft's DirectX ray tracing is one of the most popular implementations of hardware accelerated ray tracing, and plenty of game developers have started adding DXR to their games. It's not only they need ray tracing, but the thing is, you can do a really good job with rasterization. As in, we've seen games in the past do an excellent job with the rasterization to the extent that you couldn't tell whether it was ray accelerated or not. But if you do use hardware accelerated ray tracing, it provides an implementation that's much more closer to what you'd observe in real life. And the fact is, it's also very compute intensive, which is why it took GPU manufacturers this long to include it into their GPUs. And now with ray accelerators within each compute unit in AMD's cards, you have video games which can take use of, or rather make use of these features in order to get lifelike graphics within video games. And here you can see the difference between really well done rasterization on the left and a ray traced scene, the exact same scene ray traced on the right. Try to look between the two wheels and you can see the kind of reflection that is possible with hardware accelerated ray tracing, and on the left you can see the same thing being simulated with rasterization. Now we're going to pause at this particular slide and take a look at some of the questions that you've given us. There's one about infinity cache. Will infinity cache be available across the range with RDNA 2? Yes. So because this is part of the GPU and the GPU that's being used across the three SKUs are quite similar, you're going to have infinity cache, and infinity cache comes into play with 4K gaming a lot. And these are all high-end cards, which is why it becomes essential for infinity cache to be present, and they are actually present. It's purely because of the infinity cache being present that massive texture files can be pushed to the GPU and you can crunch out 4K frames at really high frame rates. Otherwise, you'd have to increase the interface width from 256-bit, which was what we saw with Radeon RX 5000 series, and that would become very intensive in terms of power consumption. So this is a more optimal way of doing these things, rather feeding data into the GPU and getting out 4K frames. So yes, this would be the better way of doing things around. Then we have another question about the price points. So you have the SEP price, which is the suggested retail price, and then you have MRP, which your local stores will provide you for that. The difference is GST. So the 6800, which would be, let me just bring up the SKUs over here. So the 6800 starts at around 50K. Then you have the 6800 XT, which is around 74-ish. And lastly, you have the 6900 XT, which is 94,388, if I'm not wrong, with GST included. And we'll move back to the slide, and we'll come back to the questions a little later. We'll go through some more slides. Now here we see the ray tracing performance of the Radeon RX 6800 XT. This is the mid SKU between the two, and some of the popular titles that were released in the past 2 years. This includes Battlefield 5, Call of Duty, Modern Warfare, Metro Exodus, and Shadow of the Tomb Raider. Now, gaming is just one aspect where the ray accelerators with an RDNA 2 GPUs can be used. The other aspect, or rather very commonly used aspect, is content creation, and we're going to see that in the next slide. Now you have several software mentioned over here. There's Blender, Houdini, Autodesk Maya. These are all several 3D modeling and authoring software that can take advantage of the ray accelerator that's present in the RDNA 2 GPUs. Now in this particular graph, we can see the Radeon Pro Render plugin being used with Blender 2.90. And the Pro Render plugin basically helps Blender make better use of the Radeon GPUs, and we can see the performance uplift of the RX 6800 XT versus the previous gen flagship, which was the AMD Radeon 7. And we can see a minimum of 49% increment, and that goes all the way up to 68% increment. These are all popular benchmarks, by the way, that we reviewers tend to use when we are testing performance in Blender. Moving on, we have two more extremely popular video editing software, Adobe Premiere Pro and DaVinci Resolve. The Radeon RX 6900 XT ends up performing up to 1.7x the performance of the Radeon 7 in DaVinci Resolve, and up to 3 times better performance in Adobe Premiere Pro. And if you try to focus on the Premiere Pro benchmark over here, it is using 4K 60 FPS footage with a lot of effects tacked onto the project. Now, when you're normally exporting a video, it's usually a CPU intensive workload, but when you add effects onto your timeline, then it becomes GPU intensive. And with a lot of effects and the footage being 4K, that too at a higher frame rate of 60 FPS, this is a very intensive benchmark, and you can see the Radeon RX 6900 XT really shine above the previous gen Radeon 7. Now that was content creation. We are getting back into games, and previously we had seen the performance of 6800 XT, and now we're going to look at the 6900 XT. Now these are all running on ultra configuration, and some of these games were some of the most GPU intensive titles when they had launched, and they've also some of these are actually quite recent as well. Across this graph, we see a nice mix of different APIs being used. We have DirectX 11 titles, DirectX 12 titles, and even Vulkan with Doom Eternal. Now you can see two graphs over here. One is a slightly lighter color, which is on the left side of each title, and you have the slightly darker color on the right. The difference over here is AMD Smart Access Memory. This is something we'll be looking at later. It allows AMD systems which use the Ryzen 5000 series processors along with the Radeon RX 6000 series of GPUs to make better use of each other's memories and get slightly more performance. Now these were games that were launched a little earlier. Some of these are older than a year, but so because they were launched a little earlier, you're bound to get more frame rate because developers had plenty of time, and even hardware manufacturers had plenty of time to come out with drivers that are optimized. Now we are looking at games that were launched in the past 2 months. So these are like really recent, and they really tax the GPU on systems that they run on. Again, you can see all the games over here run at least 60 FPS, and the card used is the 6900 XT. Again, all the settings are at the absolute maximum, and this is at 4K. So that's to say that the 6900 XT is a really good 4K graphics card. Now, here we've seen non-ray tracing performance, mostly rasterization. Next up, we'll be looking at ray tracing performance. Now, here's the 6900 XT again, this time at 1440p resolution with games that use DXR. DXR is Microsoft's implementation of ray tracing. It's called DirectX ray tracing, and you can see a good mix of recently released video games that have incorporated DXR, and the performance across the board seems to be quite healthy. We see the range of FPS from 91 going up to 139. Now, all of these GPUs also have a lot of video RAM. The entirety of the Radeon RX 6000 series have 16 GB of VRAM, which appears to be a ridiculous amount. And here we see different games that can actually put out a massive amount of memory to use. Now, Godfall seems to be leading the pack with 15.7 GB of memory, and some of these have ray tracing switched on. Okay, I am getting some message. Do we have any problems with the audio or the video feed? There seems to be some problem with the feed. Okay, I think we'll have to pause over here. Getting server error. Give us a moment while we try to figure out exactly what's wrong.